Okay, so we're going to take over where we left off on the last video. We were solving for that height, and I just gave you the value, but let's actually do all the steps here. So the range that we're given, it's 16 meters to the wall, so I plug in a 16 meters there. It's tan of 30 degrees, and I'm going to minus 9.8 over 2. It's my g over 2. And then we have 16 meters squared over initial velocity of 28, cosine of 30, and that whole quantity squared. And if you go through that, that's where you're getting the 7.1. Now there's a second way of doing that, and that would actually, you would actually have to find the time in the air first. So let's actually figure out how long it takes to get to that wall. So if I look at delta x is equal to v naught xt plus 1/2 at squared. So this is a horizontal equation, and we know for a projectile the horizontal acceleration is 0. So I have 16 meters. Actually, here we could do the algebra first. If I divide by v naught x on both sides, I get a time that's equal to 16 meters, the horizontal distance. And notice that I want to use the initial velocity in the horizontal, which we figured out to be 24.2 meters per second. And that gets us a time of 0.66. Now, if you want to go back up to the previous question here, you can take that time and then find out where it is vertically by setting up this equation. And just got to be careful that your initial velocity will be positive, so this will be a whole positive term here. And then your acceleration is a negative, so this will all be a negative term. And either way you slice it, you will get the 7.1 meters. So I want you to consider that, on the test day, you're not going to have this height as a function of range equation. I strongly encourage you to do the second method that I shared with you on test day. All right, so that's all. If you have any questions, leave them in the comments below. I hope you enjoyed watching, and enjoy the rest of your evening. Thanks for listening. Bye-bye.